HLAA, Probability and Statistics, day number 4. Today's topic is conditional probability. So we've spoken a little bit about conditional probability in that we initiated the topic of independent events. The notation for conditional probability, or typically how you'll see it, will be something like this, where the interpretation of this notation is that we are finding the probability of event A happening given that event B has already happened. And the way that we do that is we take the probability of A and B and we divide it by the probability of B. So in a then, if I were to draw a simple sample space, here's event A, here's event B. Here, of course, is their overlap. How you can interpret this is, let's say that event B has happened. What would be the probability that event A has also happened? So in doing this, we would take whatever this value is here, and we would divide it by the sum of x and y. So the probability of A or B, graphically, would be x over x plus y. And now x is clearly equivalent to the probability of A and B over the probability of B. Okay, so let's use this practically in a few examples. All right, let's first look at an example that won't necessarily use this idea of conditional probability yet, but it's a good example to consider. Weather Channel is calling for a 70% chance of rain on Saturday and 60% on Sunday. Find each of the probabilities below. What is the probability it rains only one day this weekend? Okay, so the probability that it rains only one day this weekend is saying that we want to know the probability that it rains Saturday only plus the probability that it rains Sunday only. Okay, so Saturday only, what would that look like? Well, that would be the probability that it rains on Saturday, which is a 70%, times the probability that it doesn't rain on Sunday, which would be 40%. Okay, so this is kind of like the multiplication principle. There's two events, Saturday, Sunday. There's two outcomes for each event. Okay, so rain Saturday is 70%. No rain Saturday is 30%. Rain Sunday is 60%. No rain Sunday is 40%. Okay, so go ahead and pause the video and write the probability product, right, using that multiplication rule for the probability that it rains Sunday only, which will be 0.3, which means it doesn't rain on Saturday, but it does rain on Sunday. So this would equal 0.28 plus 0.18. So the probability in this case will be equivalent to 0.46, or a 46% chance that it rains only one day this weekend. Now the probability it rains on both is going to be the probability that it rains on Saturday, and we're going to multiply that by the probability that it rains on Sunday. Now, we are allowed to do that because these are independent events. Right? Just because it rains on Saturday doesn't change the chance of rain for Sunday, at least theoretically speaking. So we're going to take the probability that it rains on Saturday, which is 0.7, times the probability it rains on Sunday, which is 0.6. That'll give us 0.42, or 42%. Now, the probability it doesn't rain on either is going to be very similar to part B, in that we are going to take the probability that it does not rain on Saturday, that's one notation that you might see, times the probability that it does not rain on Sunday. So that'll be a 0.3 times a 0.4, which should be 0.12. Now, if you look at or 12%. If you look at each of these percentages, what you'll notice is that if I were to add them up, they actually add to 100% because, right, these events, right, those three events combined cover all possible options. Okay, so we didn't necessarily have to do a calculation in Part C using the multiplication rule. We could have just added these two values up, gotten 0.88 or 88%, and taken 1 minus 0.88, which would give us 0.12 or 12%. All right, so you got some options there. That's provided that all situations or scenarios are covered by the questions within the context of the problem. All right, let's look at some conditional probability problems. Okay, a quick review of conditional probability. Probability that event A occurs, given that event B has occurred, can be calculated using the following equation. We talked about that one on the lead slide up there. So what is the probability of drawing a king from a deck of cards if it is known that the card you drew was a face card? Okay, so I want to find the probability of event A. Okay, so the probability of event A, let's say probability of event A, or event A is drawing a king. Well, that probability is 4 out of 52. Probability of event B, which is drawing a face card, there are 16 face cards. So you got Jack, Queen, King. Oops, I'm sorry, not 16, 12 face cards. You got Jack, Queen, and King of 4 suits, right? Hearts, diamonds, clubs, and spades. Okay, so 3 times 4 is 12. Okay, now, probability of B, of course, is 12 out of 52, which I'm going to reduce down to, let's divide it by 4. That'll be 3/13. Okay, so the probability that we draw a king, given that we have drawn a red card, or a face card, excuse me, will be the probability of A and B. Well, the probability of drawing a king and a face card, right, is pretty simple because all kings are face cards. So that would be 4 out of 52 over 12 out of 52. Now I could write the reduced form of 13 or 3 over 13. However, it's not really going to matter. Okay, so I'm going to make this much simpler in a moment here, but I'm going to reduce out the 52s, which gives me a probability of 1/3. So if I chose one of 12 face cards and 4 of those were kings, hey, look at that. We got a probability of 1 out of 3. Okay, so let's take a look at the example down here. So sketch the sample space for the following and find the associated probabilities. Okay, so let's sketch the sample space. All right, typical Venn diagram. Events A and B. We haven't gone to 3 events at this point. We will. Probability of A or B, 0.5. Probability of B, 0.3. Probability of A, 0.4. So I'm going to use the idea that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of both. Okay, so I'm going to sub in some values, 0.5, 0.4, 0.3 minus probability of both. Looks like the probability of both, oops, A and B, will be equal to 0.2. Okay, so I got a 0.2 here. By subtraction, I can see that I'll have a 0.2 there and a 0.1 there. Now it's asking me for the probability of A given B. So the probability of A and B is 0.2. Probability of B is 0.3. So I'm going to see that I'm going to have a 2 out of 3 chance there. Probability of A happening given B has happened. Now the probability of B given A is going to be the probability of both, which is 0.2, over the probability of A, which is 0.4. So a 1/2 chance given that A has happened, that B will also occur. Okay, let's continue with another example. All right, here we go. Given the following information, draw a sample space on a Venn and calculate the probabilities. Very similar. Okay, this is interesting in that there's an added piece here that we have independent events. Independent events tell me that the probability of A and B is equal to the probability of A times the probability of B. So let's do a quick calculation then. Probability of A and B. Oops, A and B would be equal to 0.6 times 0.7, which is 0.42. So we can do a little sketch here. Event A, event B. I'd have a 0.42 here, which would leave me with 0.18 here and a 0.28 there. So the probability of A or B would be the sum of those, which would be 0.88. Probability of A and B we already found, it's 0.42. Probability of A given not B. Okay, this is interesting. So given not B, I guess I could write this out formally, which would be probability of A and not B over the probability of not B. Okay, let's find the probabilities in both cases. Let's find the probability of not B. Well, the probability of not B would be anything out here. And with that in mind, also not in B. Anything outside of B. So what I'm going to get there for the probability of not B is 1 minus 0.42 plus 0.28. Okay, which is going to be 1 minus probability of B. This is really just the probability of B, which is going to be 0.3. Okay, so we'll get 0.3 for the denominator there. Probability of A and not B is going to be this space right here, which is a 0.18. Okay, that comes out to be 3/5, so 0.6. So the probability of A occurring, given that not B has occurred, is 0.6 or 3/5. Okay, let's continue with our last example for the notes. Okay, exam style question. A and B are such that the following are true. Probability of A is 2/5. Probability of B is 11/20. Probability of A given B is 2/11. Let's see what we can do with that. I don't necessarily need to draw a Venn diagram. I'm going to work specifically with the probability of A given B. I know that that's 2/11, and that's going to be equal to the probability of A and B over the probability of B, which is 11/20. So let's do a little algebra on that. So 2/11 is equal to probability of A and B over 11/20. If I multiply both sides by 11/20, I actually end up getting 2/20, which is the same as 1/10, will be the probability of A and B. Okay, so let's continue to answer some of these questions. Part A is complete. I've got 1/10. Part B, almost. Probability of A. Let's go with, this is part B. This, we didn't know it, but we were solving part A. Probability of A or B is probability of A plus probability of B minus probability of A and B. All right, probability of A, I'm going to write as 4/10. Probability of B, 11/20. Probability of A and B, 1/10. Let me get a common denominator. That'll be 8/20 plus 11/20 minus 2/20. So it looks like we will get 19/20 for A or B. 19/20. Determine whether events A and B are independent or not. Okay, so we know independent events. Probability of A and B is equal to the probability of A times the probability of B. So probability of A and B we know is 1/10. Probability of A was 2/5. Probability of B, 11/20. If we simplify, let's see if that's true. It looks like I would get 22 over 100, which reduces down to 11 over 50, which is not true. Not true. So in this case, the probability of A and B is not equal to the probability of A times the probability of B. Therefore, events A and B are not independent. I'm trying to write independent. It's not working. There we go, independent. All right, right on. That's it for today's lesson. It's day number 4, conditional probability. See you in the next video.